Hey guys, welcome back. So the objective of this video is to go through an example of the least square regression line, or in other words, the line of best fit. Okay, so let's go through our example. So let's say your aim in this experiment is to measure the total chemical emission concentration of the cars that passed you. Okay, so let's say you were standing at a point on the street and you counted the amount of cars that passed you. Okay, and also at the same time you had a measuring device that would measure the chemical concentrations of the cars that passed your point. So on your first attempt, let's say you counted that there were 1,000 cars that passed you. Okay, and then on your measuring device, you measured that there were a total of 9 ppm of concentrations being emitted. Okay, so that means that with the 1,000 cars, with the 1,000 cars that passed you, there was a total of 9 ppm of concentration being emitted by these cars. So then you recorded this set of data as a coordinate of 1,000, 9, okay, and you let this be x1, y1. So this is the first measurement that we have made. So with the second attempt, you again counted that there were 1,000 cars that passed you. Okay, and these 1,000 cars emitted a total of 7.7 ppm of concentration. Okay, so then you again let this be put it as a coordinate of 1,000, 7.7, and you let it equal to x2, y2. Okay, so x2 being the amount of cars that passed you, which is 1,000, y2 being the ppm of concentration, and that was 7.7. So then you keep measuring, okay? So let's say on your third attempt, or maybe on your sixth attempt, you found that there were 1,500 cars that passed you, okay? And the total concentration being emitted was 10.3 ppm. And then you record it as another coordinate of 1,500, okay? 10.3, and you let this be x3, y3. So basically you keep going in your measurements, okay? And eventually you will come up with a table. Okay, where the left-hand side is the number of cars that passed you, okay, and we let it be xi, and we have it in thousands. So here is 1,000, 1,000, 1,000. Okay, and the right-hand side we have the chemical emission, the total chemical emission made by the number of cars that passed you. Okay, and that was called yi. Okay, and this is the measurements that we have made. So the first question asks us to calculate the correlation coefficient between the two variables xi, yi. Okay, so from the last video, we introduced the concept of the correlation coefficient as the formula here, which is dependent on sxy and dependent on sxx and dependent on xyy. Okay, syy. So the thing is that SXY and SXX and SYY are dependent on these summations. So we must find these summations first. Okay, and these summations are the sum of xi, sum of yi, sum of xi squared, sum of yi squared, and sum of xi times yi. So when we have found our summations, all the summations, we can then find SXX, SYY, and SXY, and then that will allow us to plug the numbers in and find our correlation coefficient. Okay, so let's start with the summation. So let's firstly find the sum of xi, okay, from 1 to 12. So basically, that's basically summing, having summation of x1 plus x2 all the way to x12, okay? So remember up here, we have our data. So basically, you have to do a sum of x1 plus x2 plus x3 plus x4 plus x5, okay? So that's basically 1 plus 1 plus 1 plus 1.5 all the way to 3, okay? So this is what I've done here. I made a summation, okay, of 1 plus 1 plus 1 all the way to 3, okay, and that will equal to 23.5 when you plug it into the calculator. So next one, okay, we make a summation of yi, which are all the values on the right hand side of the table, okay, so these ones here, okay, so basically sum of all these numbers, okay, so this is what I've done, okay, summation of yi. Okay, so that's 9 plus 6.8 all the way to 20.6, which was recorded on our table. So when you plug all these numbers into the calculator, you should find that the answer is 157.4. Okay, so let's go on to the other summations. Okay, so the summation of xi squared is equal to 53.75. Okay, so what I mean by xi squared is if you find x1 squared plus x2 squared all the way to x12 squared. Okay, so back on the table here, right? So you basically just square this number. So find 1 squared plus 1 squared plus 1 squared plus 1.5 squared plus 1.5 squared all the way to 3 squared. Okay, and that will give you 53.75. And same thing with the yi squareds too. Okay, so when you find the sum of yi squared, that will give you 2449. Okay, so what I mean by that is, again, looking at our table, okay, when you make 9 squared plus 6.8 squared plus 7.7 squared all the way to the last number of plus 20.6 squared, okay, that will give you the summation of yi squared, which will be 2449 on the calculator. So now let's make the summation of xi times yi. So what I mean by that is basically x1 y1 plus x2 y2 plus x3 y3, okay, all the way to the last number x12, so there's a mistake, okay, times y12. Okay, so playing all the numbers, okay, so we have here, remember the x1 y1 x2 y2. So firstly, our equation, okay, in our equation we have x1 times y1. Okay, so x1 and y1, remember it was 1 and 9. Okay, so remember the data was in the thousands, so I simplified it into ones. Okay, so 1 and 9. So now we plug it in, 1 times 9. Okay, so x2, y2 was 1 and 6.8. So that's what done here, 1 times 6.8. So you keep going until you reach x12, y12. Okay, so this is what I've done here on this calculation. Okay, and this is what the summation xi yi is. Okay, it's basically 361.05. Okay, so that's what summation xi yi is. Okay, so 361.05. So then this allows us to calculate what sxy is. Okay, so sxy, okay, is equal to this summation xi times yi, which we calculated to be 361.05. Okay, so I've done here. Okay, minus 1 on 12. Remember our sample size was 12, so this is why this is 12 here. Times 23.5 times 157.4. Okay, so our summation xi, which we found at the beginning, was 23.5, and the summation of yi we found to be 157.4. So we're just subbing in all the numbers. And so when you plug all these numbers into the calculator, you should find that sxy is equal to 52.8. So when you find what sxx is, okay, which is using this formula here, okay, so summation xi squared, remember, was 53.75. Okay, so back here, summation xi squared was 53.73. Okay, minus 12, again 12 is our sample size. Okay, sum of xi was found to be 23.5, and so we need to square this number because this is what the formula says. Okay, so when you plug these numbers into the calculator, you should get sxx to be 7.73. Okay, so let's find syy, the last number. So syy is equal to this in our formula here. Okay, so n being the sample size, which was 12. Okay, so we found that yi squared, sum of yi squared was 2449 from the beginning, minus 12 times 157.4 squared. So 157.4 is actually the sum of yi. Okay, so that's what we found at the beginning too. Okay, so once you sub these numbers into the calculator, you should find that syy is equal to 384.4. So now once we have found all our sxy's and sxx and syy, okay, we can then sub it into our formula of finding the correlation coefficient, which is just basically equal to this. Okay, 52.8 divided by the square root of 7.73 times 384.4. So then when you plug into the calculator, that should give you 0.97. So basically here, I want to give you a note here. So when you calculate the correlation coefficient R, the R should be between a range of -1 and 1. So if you calculate your R to be something that's outside this range, so for example, if you calculate R to be, let's say, 3, then it's basically wrong. And I suggest you to redo all your calculations and see if you made any mistakes, because the R, the correlation coefficient, should be between the number -1 and 1. Okay? Alright guys, I'm going to continue on with the second part and the third part of this question in the next video.